Hello and welcome to a new video on my channel. Today we're gonna create this beautiful flipping card. While doing this, we're gonna learn how to create custom effect by using geometry effect protocol. We're gonna use concepts from core animation by using the CA transform 3D rotate and CA transform 3D translate functions, and we're gonna apply the result to a 3D identity matrix. Let's see a demo, and don't forget, if you want to learn more about this core animation, I will post a link with some useful information in the description. So let's see the demo. As you can see here, we have this beautiful card, and when we click on it, it flips and it displays a description. If we click back, it turns back. So are you excited to start coding? I am. So let's get started. Okay, so let's get started. The first step is to create a card. So for that we're gonna use a new struct, and we're gonna name this struct card, and it will conform to the view protocol. Okay, so we will implement the body like this, and for our card we're gonna use a rounded rectangle. So we'll say rounded rectangle with corner radius of 10, and the fill color will use a linear gradient, and for the first color we're gonna use a color that's defined in our assets catalog, named color2. And for the second color we'll use color1. The starting point will be top leading and the end point will be bottom trailing. Let's give it a frame of width 350 and height 250, and let's see how our card looks. Okay, let's hit resume, and boom, we have the card. Nice. And because we want this to be a course card, it will receive a title as a property that will be a string, default will be empty, and also it will receive a description, also a string, and also empty. Let's have an art that will be some kind of art representing the course. Let's name this simple icon, and this will also be a string and empty by default. Let's use them, and we'll say overlay, and in the overlay we're gonna do first the front of the card, and here we're gonna display the image, and we're gonna pass the icon like this, and then we're gonna display the text. We're gonna use the font, and the size will be title 2, and for the color we're gonna use white. Let's hit resume, and we should have an error. We don't have an error because these are not mandatory, but we should make them like this. The title should be mandatory, so we'll pass the title first, learn swiftui, and we'll also pass the icon, and the name of the icon I will take it from here, from the assets catalog, and I will paste it over here like this, and we'll hit resume, and yes, it looks well. So we have built the front of the card. Let's also add a shadow. Let's use this constructor, and we'll use the color that's defined in our assets catalog as shadow. The radius will be 10, and the x will be 5, and y 5. and now we have a nice shadow. Now in order to build our flip card, we're gonna need two cards. So here we're gonna use a V-stack, and this will be the front card. And for the card in the back, from the back of the card, we're gonna still use the title, and we're gonna use a description. Let's say in this video we're gonna build a flip card like this. Let's see how this card looks. Well, it doesn't look good because we need to display also the description. Now with this new version of swiftui, we can use here an if, and we'll say if icon. Then we're gonna display the icon using the image view, and if description, we're gonna display the description. Copy this like this. Here we're gonna put description, and for the font we're gonna use the body, and we're gonna use also the white. Here we'll say different than empty string, and here also different than empty string. Try again. Here let's use an alignment. If we have an icon, then it will be center, else it will be leading, and the spacing will be 10. And we are done with this part. We build the card, and now we need to create our new effect using the geometry effect. So let's do that. Now let's begin and build our new effect. And to be honest, this is the hard part, so I will post in the description a few links where you can read more about all the notions that I will use here. So let's use a struct, and we'll name this struct flip effect, and this struct will conform to geometry effect like this. And in order to conform to geometry effect, we need to implement one method, this method effect value, that will receive a size and return a project transform. Okay, and now the condition is satisfied. We know that when we perform a rotate, we need to animate the angle. So this angle will be received via props. So we'll say angle, and this angle will be a double. And because the geometry effect conforms to the view modifier protocol and also to animatable protocol, we can implement animatable data property. Let's say animatable data like this will be a double, and let's implement the get, and it will return the angle. Oh, sorry, this was why I got an error. So this needs to be implemented outside the function. And let's implement the setter. Set angle will be equal to new angle like this, and we need to know when to show the front and when to show the back. And in order to know this, we will use the state property that will be created in our content view, and it will be modified from inside our effect. So here we're gonna use a binding var, and we'll say flipped is a bool. Let's return here to satisfy this function a project transform, and as you can see, it needs to receive some kind of transform or 3D transform, and for that create a transform 3D like this. So basically this is an identity matrix. Matrices in animation mathematics are used to transform an object, screw him, move him, rotate him, and let's just return it for now, and let's also say let for now, and everything seems to be okay, no errors anymore. And we'll need to apply this to our Z stack by using the custom modifier. So we'll say here flip effect, and we need to pass a binding and the angle. So we'll say here state, and we will create our flipped variable, and by default will be false. And we also need to know when the user pressed to flip the card, so we're gonna use another state variable, var flip bool, and this will be false by default. Let's try to run this, and as you can see the card is flipped, but we have a warning. This statement will modify the view before it is rendered and or during the rendering, and to fix this we need to wrap this into a dispatch queue, an async one, and this will fix the issue. Now the code inside here will wait until the card is rendered. Let's rerun it again, and everything is okay. Let's print our angle to see the value. So and you can see we have 180. Let's try to apply this rotation to our card. We'll rewrite this variable transform 3D, which is an identity matrix. So let's apply the rotation by using a function from core animation, transform 3D rotate, and this transform 3D receives a transform 3D, that's the one from above. It receives an angles, I believe, in radians. So let me create a variable here and say angle in radians, like this. And we can see below we need to send the CG float, so let's convert to CG float, and here we'll pass our angles in radians. And these other three parameters are which axis will be affected by the rotation. So we can say we want to rotate only on Y, and we write it like this. Okay, let me run, and as you can see now we have the card off the screen. To fix this we need to apply another transform 3D function that will perform a translation, and the card is moved because the X and Y of the 3D space is in the top left corner. Let's move it to the center using this transform, like this. We're gonna pass only the X and Y, and in order to move it to the center we're gonna use minus size dot width divided by 2. This is the center of the card, and we're gonna say size dot height divided by 2, and here we're gonna put 0. Let me refresh. It looks better, but it's still not perfect. So in order to put it in the center of the screen, we're gonna concatenate another transform. This time we're gonna use an affine transform, so let me do that. And to put it back in the center of the screen, we're gonna say size dot width by 2, and like this. And here we're gonna say concatenating with this one. Let's run it. But as you can see, this is flipped. Because it's already flipped, we can see the text and the image reversed. So in order to fix that, we need to tweak a little bit our angle, and we'll create here a new constant, new angle, and if it's flipped, as you can see, we will add our angle to minus 180 to return it to the correct size. Else we're gonna return the angle, and here we're gonna send the new angle to be converted in radians. Let me rerun this. Now it looks okay, it is turned. This doesn't feel so 3D, so in order to do that, we need to define the distance projection plane. So that's the M34 property of the identity matrix, and this will be -1 divided by the maximum of the size and width, like this. And now it seems more 3D like. And also we accomplished what we wanted to do. This is how you create a flip card. We can also apply the flipping to the x-axis, and it will look like this. And this is it. This is how you create a flip effect. There was a little bit of math, a little bit of core animation. I will post in the description some links to read more about core animation and transforms identity matrices. If you like the video, don't forget to hit the like, and if you are not subscribed and want to receive more news from my side, don't forget to hit the subscribe button. Until the next time, I wish you all the best.